We're going to be talking about prime and composite numbers. And in order to discuss this topic, we need to have some background vocabulary. So on your teacher side, we're going to write the definition to a few words. The first word we're going to talk about is what is a prime number. A prime number is a number that only has two factors, the number 1 and itself. It is not divisible by anything except for 1 and itself. For example, if I have the number 7 and I go through all my divisibility rules using the T-chart method that you were shown in class today, no matter what I do, all the rules I go through, I would only be able to find 1 times 7 to equal 7. And that means I can't do anything else, and so this number is prime. Another key vocabulary word we need to know is what composite means. A composite number is different than a prime number because it can have more than two factors. So it has sometimes two sets of factors all the way up to tons of sets of factors. So whereas prime number had one set, which was 1 in itself, composite has 1 in itself, and then there'll be other numbers that it's divisible by. So let's look at the number 8. If we use our T-chart like you learned at school today, it's 1 times 8, and then 2 times 4, and then you're done with that. And so it is composite because it was not just 1 times itself, but also some other numbers went into it. So this one is a composite number. We're also going to talk about what a factor tree is. A factor tree is actually a diagram that's used to show the prime factorization of a number. Well, what is prime factorization? Got to know what that is in order to understand what a factor tree is. Prime factorization is when you get all the prime numbers that can be multiplied together to get a composite number. And we will be doing some examples so it'll make sense in just a second. Okay, we're going to practice finding out if a number is prime or composite, and then we're going to do some prime factorization using factor trees. So let's just look at the number 41. I want you to try this on the student side. I want you to use your T-chart method to see if you can find out if 41 is prime or composite. If you find that it only is 1 times 41, then you'll know it's prime. If you find that it's 2 goes into it, or 3 goes into it, or any other number, then you know it's a composite number. Okay, after you've tried that, you did your T-chart, 41's on the top, you know that 1 goes into it because 1 goes into every single number. 1 times 41 is 41. When you go through 2, this is not an even number, so that doesn't work. The rule for 3, 4 plus 1 is 5, so 3 won't go into it. And you could go on and on. You're going to find that there are no other factors of 41, so 41 is prime. By the way, very important to note that the number 1 is not prime or composite because it goes into every single number. It is not included on the prime side or the composite number. It is neither of the two. Alright, let me show you now how to do prime factorization using a factor tree. We're going to start with the number 24. And you can go about this several different ways. There's not a right or wrong way to get there as long as you get to the right prime factorization. 24, I can break it into 8 times 3. Okay, I'm going to look at these two numbers. 8, I know I can break down farther. 3, I can't. It's prime, so I'm going to stop right there with that one. When you are doing factors, factors are what we call decomposing. What it means to decompose is to break down. So anytime anybody tells you to factor something or to decompose something, you're going to break it down. You're going to try to get it to look smaller than its original. So we're going to be using smaller numbers. Can't be the 24, okay? Well, 3 was prime, so I stopped. I know that I could do 2 times 4 to get 8, okay? I know that 2 is a prime number because I can't break it down any farther. Well, I know that 4 is composite, so I'm going to break down again. 2 times 2 equals 4. That is prime as well. So I have no more numbers left on my tree to break down. So I'm going to look at all the numbers that I underlined. I have a 2. I write it down. I have another 2. I write it down. I have another 2. I write it down. And I have a 3 up here, and I write it down. I always want to write them in order from least to greatest. It's just easier that way. And then I'm going to stick a multiplication sign in between because factoring has to do with multiplication. And then when I multiply all these together, I should end up with the number I started off with in order for it to have been a successful prime factorization. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So this is my prime factorization for the number 24. I could have got at it a different way. I could have done 6 times 4. It doesn't matter as long as I ended up with these 4 prime factors. Prime factors together in a multiplication problem create a prime factorization. I want you to try one by yourself. Go ahead and pause me when I put the number up, and then you'll see if you got it right. Let's do the number 20. All right, let's see how you did after you paused me. If you didn't pause me now and do it. Okay, I know 2 times 10 is 20. Some of us might have done 4 times 5. One way is not better than the other as long as I know that I'm going to get to the same end result. Okay, 2 is a prime number, so I'm done with that one. 10 breaks down into 2 times 5. Well, 2 is prime and 5 is prime because there's nothing else I can do to break down or decompose those numbers. So my prime factorization, I'd write down my 2, my next 2, my 5. So 2 times 2 times 5 is the prime factorization of 20. Now watch how this is going to work out the same way. I know that 5 is prime. To get 4, I do 2 times 2. They're both prime. And so I use this same method. I have a 2. Got it. I have another 2. Got it. I have a 5. 2 times 2 times 5. Let's check it to make sure. 2 times 2 is 4. 4 times 5 is 20. I am correct, and that's the exact same thing. So it didn't matter which way you started. If you got to the end result the same, you're good. Your prime factorization, if you think you have prime factorization, all the numbers in that should be prime. If I have a 4 in there or a 6 in there, I know that I've done something wrong. You'll be doing